66 million years ago, an asteroid slammed into Earth and wiped out the dinosaurs. It triggered wildfires, earthquakes, tsunamis, and plunged the world into darkness for years. Around 75% of all species went extinct. But what if that same asteroid struck Earth today? With our advanced technology, cities, and survival instinct, could we make it? Or would we vanish just like the dinosaurs? Let's find out. The asteroid is 10 to 12 kilometers wide, about the size of Mount Everest. It's moving at 72,000 kilometers per hour, fast enough to cross the Atlantic Ocean in under 5 minutes. It enters the atmosphere glowing white hot, slamming into the Yucatan Peninsula in Mexico. The explosion releases energy equal to 100 trillion tons of TNT, or more than 10 billion Hiroshima bombs. A fireball rises higher than Mount Everest. Everything within a 1,500-kilometer radius is vaporized instantly. Skyscrapers, forests, entire cities, gone in a flash. More than 100 million people in the region die instantly. And the worst is still to come. The blast hurls molten rock and ash high into the sky, and much of it falls back down. This triggers a planet-wide firestorm. Red-hot debris rains down from the upper atmosphere, setting buildings, forests, and vehicles burning across multiple continents. Entire regions catch fire. The sky glows orange as flames sweep across the land. The heat is so intense that it ignites wood, plastic, and fuel instantly. Even parts of the ocean near the impact site begin to boil. Our power grids collapse. Satellites are disabled by the radiation. Global communications go dark. The force of the impact causes the Earth's crust to ripple. Earthquakes with magnitudes between 9 and 11 are triggered across the planet. That's stronger than any earthquake ever recorded. Meanwhile, the asteroid's shockwave causes mega-tsunamis, waves over 100 meters tall. These monster waves crash into coastlines around the Atlantic and beyond, wiping out ports and cities. Some estimates suggest that up to 3 billion people living near coastlines could be in immediate danger from flooding and collapsing infrastructure. Next, a thick cloud of dust, sulfur, and ash spreads across the atmosphere, circling the globe. Sunlight is blocked. Temperatures drop sharply, and we enter an impact winter that could last anywhere from 5 to 15 years. No sunlight means no photosynthesis. Crops fail, trees die, oceans cool rapidly, disrupting marine ecosystems. Most food sources vanish. Within months, global famine would set in. Humanity wouldn't just be dealing with fire and floods, but a cold, dark world with nothing to eat. Now here's the big question. Could modern humans survive this? Surprisingly, yes. Some of us could. When the asteroid hit 66 million years ago, species like crocodiles survived by hiding in water and not needing food for months. Small mammals survived by sheltering underground and eating seeds and insects. Today, humans could do something similar. Across the globe, there are millions of underground shelters, bunkers, mines, and subway systems. In Switzerland alone, there's enough underground shelter space for the entire population. The US government maintains massive doomsday facilities like Raven Rock, and other nations have similar systems. Even ancient underground cities like Derinkuyu in Turkey could serve as protection. If people reach shelter before the fallout, millions, maybe billions, could survive the initial event. But surviving the impact is only step one. The next challenge is living in a world without sunlight. Farming would collapse. Grains, fruits, and vegetables can't grow in darkness. Temperatures will drop below freezing in most places. To stay alive long term, survivors would need indoor, artificially lit farms growing sunlight-independent food like mushrooms and algae. Algae could become humanity's main food source. It's rich in nutrients, can grow in low light, and doesn't need soil. Water would need to be stored in sealed tanks underground to protect it from acid rain and toxic ash. Some countries, like Iceland, could use geothermal energy to power underground shelters and farms. Others might turn to nuclear power to keep essential systems running. The survivors would be cold, crowded, and hungry, but alive. Outside the shelters, society would collapse. Governments would fall. Fights over food, water, and shelter would turn violent. Billions more could die in the chaos that follows. But beneath the surface, small communities could survive. Subways, mines, and deep shelters could turn into underground cities. There are more than 20,000 kilometers of subway tunnels worldwide. But with rapid adaptation, they could house millions. These survivors would rebuild slowly. With limited tech, knowledge, and power, humanity would start over in a colder, darker world. Let's say we saw it coming. Would we stand a chance? In 2022, NASA launched a test mission called DART, the Double Asteroid Redirection Test. It deliberately crashed a spacecraft into a small asteroid, 11 million kilometers from Earth. And it worked. The impact slowed the asteroid's orbit by 32 minutes. It was a major breakthrough, the first time humans changed the path of a space object. But that rock was tiny, only about 170 meters across. The one that ended the dinosaurs? More than 10 kilometers wide. A mountain falling from the sky. Stopping something that massive wouldn't take just one spacecraft. It would take years of planning, dozens of launches, and a coordinated global response. We'd have to hit it early, while it's still millions of kilometers away. The sooner we act, the smaller the push we need to steer it off course. Other options are still experimental. Solar sails to drag it off path, lasers to slowly push it, even painting one side white so sunlight heats it unevenly and alters its course. But all of these solutions take one thing we may not have: time. Years to design, years to build, years to launch. And there's a catch. If the asteroid came from outside our solar system, a rogue object drifting in from deep space, we might not have years. We might only have months, maybe even weeks. And that's assuming the world actually works together. Which, let's be honest, history hasn't always shown. In a real crisis, panic in politics could cost us the one thing we can't afford to lose: time. Humanity has never faced a challenge like this. Not war, not climate change. Not even a pandemic compares to the scale of a planet-ending impact. This is more than a scientific problem. It's a test of something deeper. Our ability to think beyond ourselves, to cooperate beyond borders, to act not out of fear, but out of foresight. Because the question isn't if another asteroid will come, it's when. We've already been hit once, and it could happen again, in 1,000 years, or next Tuesday. The dinosaurs ruled Earth for over 160 million years. But they didn't have warning systems. They didn't have rockets. They didn't have a chance. We do. And what we do with that chance could decide the future. Not just for us, but for every generation after us. If this video made you think, hit that like button. Subscribe for more real what-if scenarios.